We have known for a while about the large-scale structure of the universe. Galaxies reside in filaments hundreds of millions of light years long on a backbone of dark matter. And where those filaments meet, there are galaxy clusters. Between them are massive voids where galaxies are sparse. These massive filaments are rotating, and this kind of rotation on such a massive scale has never been seen before. Today, we will discuss with you about the largest rotating object in the universe. Welcome back to Signature's Life, and you're watching Signature's Science. Obviously, there is no way to take an actual picture of the universe's large-scale structure. But there are some most famous images that come from the Millennium Simulation program. The Millennium Simulation was a supercomputer simulation of a cubic portion of the universe over 2 billion light-years on each side. The image contains about 20 million individual galaxies organized in filaments and clumps. It's remarkable to look at that image now and imagine those filaments rotating. The team of astronomers behind this discovery worked with data from the Sloan Digital Sky Survey. The survey created a very detailed 3D map of the universe, so the Sky Survey data was critical to the team's discovery. Each of the galaxies in the filaments amounts to no more than a speck of dust on the grand scale, and they are not only rotating but moving along the tendrils as if they are pipelines. Despite being thin cylinders similar in dimension to pencils, hundreds of millions of light years long, but just a few million light years in diameter, these fantastic tendrils of matter rotate. On these scales, the galaxies within them are themselves just specks of dust. They move on the helices or corkscrew-like orbits, circling around the middle of the filament while traveling along it. Such a spin has never been seen before on such enormous scales, and the implication is that there must be an as yet unknown physical mechanism responsible for torquing these objects. The fact that these filaments spin is difficult to visualize and fascinating once you succeed. But the discovery is about more than our own fascination. These are the largest objects we have ever seen spinning, and that means that angular momentum can take place on a massive scale. One of the mysteries in cosmology is how that angular momentum is generated on such a massive scale, since there was no primordial rotation in the early universe. The discovery rests on observations of individual galaxies in the filaments and their Doppler shift. In this study, redshift is a proxy for rotation. Redshifted galaxies are receding and blue-shifted galaxies are approaching. In the current working model of the universe's structural formation, our densities grow via gravitational instability. Material from under-dense regions flows into regions of over-density, but that flow of material has no rotation or cool to it. That's why cosmologists say that there was no rotation in the early universe. And here's where the discovery gets more interesting. The rotation evident in these filaments of galaxies must be generated as the structures form, and these filaments and the rest of the cosmic web are connected to the formation and evolution of galaxies themselves. They also have a powerful effect on the spin of individual galaxies and can regulate how a galaxy and its dark matter halo rotate. There is an unknown pace in all of this. Scientists don't yet know how our current understanding can predict that the filaments themselves spin.